In part 3 of this course, we worked through almost 40 modules discovering the intricacies of the peer-to-peer SIP call. Back in the very first lesson, we discussed how SIP, being a protocol to initiate a session, does two key things that are essential to setting up a voice over IP communication. What are they, and how is each implemented through SIP? Well, take a moment to think and then press play when you're ready, and we'll compare notes. SIP helps both parties discover each other's location or IP address, and it helps both parties know which codecs to use for media encoding. We've already discussed the codec negotiation role in detail, how the caller and the callee exchange media options in the invite and the 200 OK, how they send media packets to the supplied IP and ports, and how they use the first codec common in both offers. We've dealt with that one, so what about the other? How has SIP helped both parties discover each other's location? Well, so far in our studies, it hasn't. Not yet, at least. In fact, think back to your first SIP call. Before dialing, we had to look over and get the IP address and port of the other client, then manually type it into the address field. We haven't looked yet at how SIP helps clients discover each other's location, simply because in a peer-to-peer call, clients can't do that for themselves. They need help. Help from two SIP services, the registrar and location service. In fact, that's the topic of this next chapter. By the time you've completed this next batch of lessons, you should understand very well the role of the registrar and location service, how a user agent client registers with the registrar, and how it then exploits a location service to discover the address of the dialed party. Now, the SIP server typically sits in the network core, doing things for endpoints that they can't do for themselves. The SIP specification, RFC 3261, defines 4 foundation services, including the registrar and location service. And being extensible, there's also a whole bunch of other services defined by various SIP extensions. Now, as we begin discussing servers, it's important to remember that SIP servers have a very different mentality to traditional PSTN servers. Whilst PSTN switches are very much call-centric, architected and built to set up circuit-switched calls, SIP servers are very much applications-centric, designed to offer services to the packet-switched network. Today's real-world communications networks will have many SIP servers. There'll likely be session border controllers and PSTN gateways at the access layer, session management servers at the management layer, and conference servers, IP PBXs, voicemail servers, feature servers, presence servers, mobility servers, messaging servers, and more, all at the application at the services layer. Now, all of these services at all 3 layers are all SIP servers with common SIP characteristics and perhaps a subset of core capabilities, each then with additional capabilities built on top. First, though, let's study the foundation core services, beginning with registration and location.